Timescape cosmology, the universe that shatters time. Asterisk, the distinction between past, present, and future is only a stubbornly persistent illusion. Albert Einstein asterisk. A crisis in the cosmos asterisk asterisk. In a recent gathering that could only be described as historic, some of the most brilliant minds of our era, Nobel laureates, theoretical physicists, cosmologists, and astrophysicists, came together not to celebrate their latest triumphs, but to confront an unsettling possibility that our understanding of time and the universe may be fundamentally flawed. What triggered this intellectual emergency? A single question that pierces to the core of science itself. Does the universe truly have a uniform age? For over a century, the prevailing cosmological narrative has been relatively unchallenged, that the universe began in a titanic event, the Big Bang, approximately 13.8 billion years ago. Since that primordial flash, space has been expanding, cooling, and giving rise to the cosmic structures we now observe: galaxies, stars, planets, and eventually life. But recent data from the James Webb Space Telescope, jwst, the most powerful observatory ever built, has begun to unravel that story in ways both shocking and profound. With its infrared gaze, Webb has peered deeper into space and further back in time than ever before. And what it has found is almost unthinkable. Galaxies, fully formed, complex, older than the Big Bang. Chapter 2. The Inconvenient Galaxies. To put this into perspective, light from distant galaxies takes billions of years to reach us. By observing these ancient galaxies, we are looking directly into the cosmic past. Yet, some of the galaxies jwst has detected seem too developed, too structured, to have formed so soon after the supposed beginning of time. According to the Standard Model, galaxies should not have had enough time to form their intricate shapes or mature into such massiveness. These are not faint smudges or mere anomalies. These are massive, ancient structures that challenge the very foundation of our cosmological framework. The existence of such galaxies calls into question not just the timeline of galactic evolution, but the very nature of the universe's origin. Suddenly, the Big Bang, once considered scientific bedrock, has been thrown into uncertainty. Were we wrong all along? Chapter 3. Timescape Cosmology, a New Framework. Amidst this chaos of discovery, one model has risen to prominence, offering an explanation that is as radical as it is elegant. Timescape cosmology. Unlike traditional models that assume a single synchronized cosmic clock ticking uniformly throughout the universe, timescape cosmology suggests something far more complex and beautiful, that time flows differently depending on where you are in the universe. The concept is rooted in Einstein's general relativity, which already tells us that gravity and acceleration affect time. Atomic clocks at higher altitudes tick slightly faster than those at sea level. Time bends in the presence of mass. But timescape cosmology pushes this idea to a cosmic scale. In this model, dense regions of matter, like galaxy clusters, experience slower time, while vast, empty voids in the universe allow time to flow more quickly. In other words, time is not absolute. It is not universal. It is profoundly local. This revelation means something astonishing. There is no single age of the universe. Different regions could have aged at different rates. Billions more years could have passed in cosmic voids than in dense galactic regions like our own. The cosmos, therefore, is not uniformly 13.8 billion years old. It is an ever-shifting mosaic of regional chronologies. Chapter 4. The Death of Dark Energy? The implications of this are seismic. For example, one of the great mysteries of modern physics is dark energy, a hypothetical force said to be driving the accelerating expansion of the universe. Its presence was inferred not by direct observation, but by how galaxies appear to move apart from each other faster than expected. But what if this perceived acceleration is an illusion? If time flows differently in different parts of the universe, our measurements of cosmic expansion would be fundamentally skewed. The acceleration might not be real at all, but rather a product of time dilation across the vast, varied topography of space-time. If so, dark energy, an entity that comprises about 70% of the universe in standard models, could be nothing more than a mathematical mirage. Chapter 5. A universe without a beginning? The most provocative suggestion of timescape cosmology is that the universe may not have had a single, unified beginning. If time doesn't move at the same rate everywhere, then a single start point becomes meaningless. The Big Bang may have been a local event, or a phase in a much larger and more complex process. This is deeply aligned with other alternative models like cyclic cosmology and conformal cyclic cosmology, which propose a universe with no beginning or end, only repeating cycles or transformations. Chapter 6. Time, Consciousness, and Human Perception. If time itself is fluid, inconsistent, and possibly illusory, then what does that mean for us? Are we, as biological and conscious beings, tied to our perception of time simply because of where we are in the cosmos? Could the human experience of time be nothing more than a byproduct of living in a dense matter region of the universe? This opens a Pandora's box of philosophical and even spiritual questions. What is aging if time is not fixed? Could there be places in the universe, or even phenomena on Earth, where time flows differently? Could these be the source of ancient mysteries, lost civilizations, or unexplained technologies like the construction of the Egyptian pyramids? While this may sound like science fiction, timescape cosmology forces us to rethink what was once dismissed as myth or speculation. Chapter 7. The New Science of Time Spheres. Imagine a universe not ruled by a single clock, but instead composed of overlapping time spheres, each flowing at a unique rate, influenced by the density of matter and the curvature of space-time. In this picture, interstellar civilizations could exist in time zones so different from ours that communication would seem impossible, or at least unimaginably strange. This model could also explain the great cosmic silence, the Fermi paradox. Other life forms might simply be evolving, living, or decaying in different temporal dimensions. Perhaps they're not ahead or behind us in time. They're simply moving through it in a completely different way. Chapter 8. Toward a Quantum Leap in Human Evolution. If we were to fully embrace this new view of time, our societal structures, built around synchronized hours, days, and years, would become obsolete. We would no longer organize our lives around arbitrary clocks. Instead, we might develop time-independent senses, a kind of intuitive synchronization with the universe's fluctuating rhythms. This would require not just a scientific transformation, but an evolution of consciousness. The implications stretch from cosmology into biology, psychology, and spirituality. If aging is not inevitable, but a byproduct of our location in space-time, could we learn to slow or stop it? Could life extension, or even immortality, emerge from mastering the flow of time? Epilogue. The edge of a new worldview. Timescape cosmology is not science fiction. It is a scientifically grounded model born from Einstein's own theories, supported by data from the most powerful telescope humanity has ever built. It is a theory that forces us to let go of certainty, to embrace a more fluid, dynamic, and local conception of the universe. As we peer deeper into the cosmos and discover ancient galaxies that shouldn't exist, as we puzzle over the conflicting measurements of the Hubble constant, and as we question the very idea of a universal beginning, we stand at the threshold of a profound scientific and philosophical transformation. The universe may not be what we thought, and neither are we.